Hello, everyone. I'm Won Zhang from Hefei University of Technology. Today, I'm honored to present our work Moderating the Generalization of Score-Based Generative Models in collaboration with colleagues from UCL, SDSU, and Beihang University. I'd like to start with this quote from the philosopher Edmund Burke: "The greater the power, the more dangerous the abuse." This perfectly describes the dilemma we face today with powerful generative models. The stronger their ability to generalize and create realistic data, the greater the risk of unintended misuse, such as privacy leakage, copyright infringement, and style imitation. Our work begins from this very concern. How can we moderate the power of score-based generative models so that they remain creative but not abusive? Score-based generative models, or SGMs, have shown remarkable ability to generate unseen yet realistic data. However, with greater generalization comes greater risk. These models may unintentionally reproduce sensitive faces, copyrighted artworks, or even private training data. We refer to this as unintended generalization, which can lead to serious ethical and legal concerns. A natural question arises: can we make generative models forget undesired data? Machine unlearning, MU, has been explored in classifiers and DDPMs, yet these approaches rely on discrete, time, or conditional objectives, and cannot be directly applied to continuous time SGMs. DDPMs optimize an elbow, whereas SGMs depend on score matching. This fundamental gap makes existing MU methods ineffective for unconditional generation. Even the so-called gold standard retraining after data removal fails in SGMs. In toy Gaussian and real-world experiments, retrained models still regenerate the forgotten samples. The reason is simple. Retraining does not modify the score function. The gradients near forbidden regions remain nearly unchanged, so the model continues to reproduce the same data. This observation motivates us to rethink unlearning at the score function level. Our key idea is straightforward yet powerful. Directly modify the score function to steer sampling away from not suitable for generation NSFG data, while preserving the score for suitable for generation SFG data to maintain quality. Instead of retraining from scratch, we moderate the model's generalization by reshaping its score landscape. We propose two complementary strategies. Orthogonal MSGM explores the orthogonal complement of the score function W.R.T NSFG data, guiding sampling away from undesirable regions, effective when distributions are moderately separable. Obtuse MSGM relaxes this to a negatively correlated direction, suitable for highly overlapping distributions, for example, removing bangs from faces without harming realism. Together, they form a unified framework for controlling the generalization of diffusion models. Mathematically, we minimize the distance to SFG data while maximizing the distance from NSFG data. This becomes a score matching problem with two losses: one for generation and one for unlearning, orthogonal or negatively correlated. A balance coefficient alpha controls the trade-off between generation quality and forgetting strength. In a toy Gaussian example, MESGM significantly changes the score directions, red arrows, steering trajectories away from the forbidden region. Consequently, generated samples almost completely exclude undesirable clusters, while retraining still reproduces them. This shows that MSGM truly reshapes the generative manifold instead of merely filtering outputs. We evaluate MSGM on 5 datasets: MNIST, CIFAR10, STL10, Celebe, and ImagineNet, using SGMs and DDPMs. SGM achieves lower unlearning ratios and higher NLL for forgotten data, proving it effectively reduces their generation probability. It transfers well to downstream tasks like in-painting and reconstruction, and can be plugged into Stable Diffusion v1.4 for text-to-image forgetting without pseudo-labels. To summarize, we present MSGM, the first unlearning framework for score-based generative models. By moderating the score function directly, MSGM controls unintended generalization. surpasses existing gold standard approaches, and generalizes across diverse diffusion backbones. We hope this work inspires future research on safe and controllable generation. That concludes all the content of this video. Thank you for watching. If you're interested in our work, we invite you to read our paper for more details. In addition, our code has been made publicly available, allowing everyone to further explore and build upon our research. Thank you again for your time and attention.